All right, scientific notation. This is just changing from scientific notation to standard and standard back to scientific notation. So scientific notation is a way to write really, really big numbers and really, really small numbers using powers of 10. This is the book definition of it. But the key that you have to watch out for is that you move the decimal to the left or to the right, depending on what you're doing, until you have a number between 1 and 10. Okay, 10 is not included. Okay, so that really it's between 1 and 9. 10 is not included. Count the number of places that you moved. If you move to the left, you have a positive power of 10. All right, so let me start. We have an understood decimal here at the end. Okay, I move it once, and I end with 456. That's not between 1 and 10. Move it one more time, and it's 45. Not between 1 and 10. Move it one more time, and you've got 4. 4 is between 1 and 10. You can do that symbol or the dot. Now we move the decimal to the left 1, 2, 3 places into the third. All right, now here's where I start to get a little lazy. So I've got a bunch of zeros. There's 3 zeros here. I know if I move the decimal, that's 3 decimal places. I've got another 3. Okay, and I'm still at 157, so I gotta move it again. That's 15. Move it one more time, that's 1. Now, you only list the non-zero digits. 1.57 times. Now we moved 3 and another 3, so that's 6, 7, 8 times. Okay, so on this one, move it once, that's 7,820. Twice, that's 782. 3 times is 78. 4 times, that makes your 7. You only list the non-zero digits there. If you have zeros at the end, they don't get listed. Times 10. That was 1, 2, 3, 4. All right, move it those first 3 zeros. That's still 4,786. One more time, that's 478. One more time is 47. One last time, there's your 4. We have these 3 zeros at the end. They don't get listed, but your 786 does. Now, how many places did we move? 3, 4, 5, 6. So these numbers were really, really big numbers in scientific notation. We moved the number to the left. Now we're talking about taking really, really small numbers and putting them in scientific notation. This time, we move it to the right. Okay, you still need to make a number between 1 and 10. Really, it's 1 and 9. Count the number of places that you moved. This is your negative power of 10. All right, so I'm going to move this to the right one place. Well, that's still 0.61. My number needs to be between 1 and 9. Move it to another space. Well, now I have 6.1. 6 is between 1 and 9. How many places did we move? 1, 2 to the right. So that is negative 2. All right, 1, that's 0.00052. So no. 0.0052, no. 0.052, no. 0.52, almost. 5.2, there we are. You only list the non-zero digits, so if you have a bunch of zeros in front, they don't get listed. Now, how many times do we move to the right? 5. So move the decimal to the right one space. That is 9.8. 9 is between 1 and 10. That's good. You only moved it to the right, 1 space. There we are. Right, move it once, and we have 0.000092. No. Another space, that's 0.00092. 0.0092. 0.092. 0.92. And 9.2. There's where a digit is. And that was 1, 2, 3, 4, 5, 6 places. Last part is taking what's scientific notation, putting it back in standard form. So move the decimal, you're going exactly the opposite. Move the decimal to the right if your power of 10 is positive, left if power of 10 is negative. The exponent tells you the number of places that you move, and if you have to move a space that's empty, you put a 0 there. Positive 2, meaning you're moving to the right. So 1, 2. Negative 3 means move to the left. So I'm going to put this down here. 1, 2, 3. So I've got an empty jump right here and another empty jump right there. They get zeros. Now, if it makes you feel better, put a 0 in front of the decimal. That doesn't change anything, but you don't need it. Positive 6, we're going to write 6 places. I'm going to rewrite it so we have space. 1, 2, 3, 4, 5, 6. So I have 4 jumps. 1, 2, 3, 4. So each of those empty spaces gets a 0. 1, 2, 3, 4. This decimal place is negative, or this power of 10 is negative, so we want to go left 5 units. So 1, 2, 3, 4, 5. So I have 1, 2, 3, 4 empty places. 1, 2, 3, 4. Again, you can put a 0 in the front, it's not going to change anything. Positive power 8, so write 8. 1, 2, 3, 4, 5, 6, 7, 8. So I have 1, 2, 3, 4, 5 empty spots. So 5 more zeros. 1, 2, 3, 4, 5. And negative 7 there. So this is left 7. So 1, 2, 3, 4, 5, 6, 7. So that gives me 1, 2, 3, 4, 5, 6 empty spots. 1, 2, 3, 4, 5, 6. Again, you can put a 0 in front if it helps. And I'm not even going to try and read this number. A light year is this giant number of meters. Is how far the light travels in 1 year. Okay, so that's a long time. Write this number in scientific notation. So from the end, that's 3 zeros, another 3, another 3, another 3. So I've moved 12 spots right now, and I'm still at a number that's 9,460. My digit has to be between 1 and 10. So 1 more, it's 946. 1 more is 94. 1 more is 9. You have all these zeros at the end. You do not need to list them. So going from standard to scientific, we move to the left, your exponent is positive. So it flips, goes vice versa. So that was 3, 6, 9, 12, 13, 14, 15 places. Same idea on this one, so the parsec. I'll write this in scientific notation. So 1, That's 3, 6, 9, 12. I'm going to go ahead and move another 3. But even when I move it here, that's still 30, so I need to move it 1 more. So that was 3, 6, 9, 12, 15, 16.